Hey Jordan, it's Jared. It's Monday, the 24th of February. Just getting back to you. I apologize I didn't respond this weekend, but I had to enjoy the warm weather with my kids. And so I'm going to talk through your reflection just a little bit, talk through my notes from the observation last Friday, and then also get to some of your work sample questions. And so I'm probably going to start and stop this video a couple of times, try to make it as brief as I can, but I do want to encompass as much as I'm able to. So first of all, thank you for your reflection. I appreciate your authenticity, your openness, willingness to admit areas. At one point, I think you said something was like, it was just chaos or it was a disaster. I've totally been there. And I thank you for, first of all, recognizing that and admitting that. In terms of your survey of chemistry class and this idea of review, it's going to look different for every student, and every student's expectation is going to be different. I can just about picture your clientele for this class. I'd love to get into one of these classes at some point in the future for the next observation. But my suggestions are limited. What I would say is that there's certainly a part of review that can be done independently, and you have a little more control over that, right? You're handing students a packet of some sort, you're asking them to respond to questions you have up on the board, and they're doing that independently or maybe with one table partner. Oftentimes teachers just live in that world, and that's how they do all their review because they have the most control over it. So I commend you for trying something different, trying something more interactive, more engaging for students. But you saw the flip side of that as well, where certain students weren't able to handle the freedom that you allowed them. And that's what creates the chaos, is you have less control when you hand more of that control over to the students. So a couple of the things that I would suggest, just based on my own experience when I'm trying to do review of that nature, is be as specific as I can in my directions and my expectations, and follow through with whatever the procedure is to try to create as much control even amidst the chaos as I'm able to. And then also look for the outcomes. Like at the end of that activity, did most students get what you wanted them to get out of the review or not? And if not, even though there might have been some chaos, if students did get what you wanted them to get out of that activity, then it was a success for most students. If most of them didn't get what you were hoping that they would, then it's probably time to think about ways that you might tweak that a little bit. And so some things that you could do would be, first of all, to ask other colleagues if they have ways to make the review more active and more engaging for students, and maybe try some of those activities. There are going to be some things that you can do with your physics class that you're just not going to be able to do with your chemistry class, as far as review and activities and that type of thing. The other thing would be just not to be afraid to try new things. If you find something that works and it clicks and it has enough structure that students are able to focus and they're comfortable enough with it that it's a success, then you might want to continue with that. One recent example that was brought to my attention of a way to review, probably mostly for vocabulary, but there might be a way for you to incorporate this into, I don't know, equations or something else as well, is for you to divide the class into 2 or 3 or 4 teams, and they create single file lines of chairs. And you make it very clear that it is a competition, a light competition, and maybe there's some light reward at the end of it. I don't know. You don't want to encourage too much competition, but you want to kind of try to motivate students, try to get them excited about whatever it is you're going to do. And so you have these different teams, and you make it very explicit at the beginning that there's not to be any talking at all. And if there's talking, you're disqualified, or you lose a point, or you come up with some kind of minor consequence. Not so that they give up and sabotage the whole thing, but that they take it seriously. And then you have some terms that you have up in the front of the classroom, and you give each term to the person in the front sitting in that first seat. And then what they have to do is they have to flip that card back behind them all the way to the end, where there's like a word bank full of other cards. And the person who's sitting in the back of the row has to determine, once they get the card that the teacher handed and went down, they have to match that or pair that with the correct mate. And then what they do, again, no talking at all during this whole exercise, but they take what they think is the pair and they start passing it forward. Again, there's no talking, but each member of the team has to take a look at that. And if they don't think that's the right one, then they have to pass it back. If they think it is the correct one, they move it forward. And so we move backwards and then up to the front to see which team is able to do that most quickly. Now that's just one example that may or may not work for your class. I don't know the size, I don't know the composition of your class, but those are the types of activities where setting those explicit directions at the beginning and saying, hey, there's no talking at all, and there's going to be a little bit of laughter, there's probably going to be a kid who intentionally falls out of his chair, some of those types of things, but it allows students to be able to review. It allows them to be active and be engaged, but by requiring silence, you're still given some measure of control over the process. And then the idea would be, once each team goes through and is successful, then students just rotate. So the person in the front moves to the back and everybody moves up the chair, or whatever the case is. But that allows every student to see the term, every student to see the definition, or maybe the equation and the process of going through it, whatever that might look like in chemistry. Maybe it's the element and I don't know, some information about that element. So that'd just be one example of a way you might try to activate students or get them involved in the review process, while still maintaining some control over and some expectations for the learning. As far as labs in your physics class go, this is something that I questioned, and we'll get to in your observation, the notes I took over your observation, but it seemed to me like you had just had each group responsible for one lab report. So the simplest way to probably ensure that all students are at least doing some minimal work is to require each student to actually go through the lab process and show their learning and their thought in a lab report. The other thing would be maybe just finding a way to rotate lab partners and recognizing that not every group is gonna click. Part of that's just life, right? Not every teacher that you collaborate with at all times are you gonna agree with and work as effectively with as others. So I think we need to prepare students for that reality, and then also just recognize and emphasize that we have expectations. They're going to do the heavy lifting. I don't know that like a punitive approach would work as far as isolating or singling out a partner so that somebody had to do it alone. I don't know that that's the best approach for this. Maybe there's an opportunity where, depending upon the regularity of your labs, that you allow every fourth lab or every fifth lab, you allow students to choose partners and maybe even group sizes. I don't know. A lot of that depends on the nature of the lab and what is the most effective group size for that. But as I mentioned in dealing with the chemistry activities, the review activities, I think you're thinking in the right way by trying new things, by trying new pairings, by seeing what seems to click and work best for the largest number of students. So that's what I would say in regards to your physics. Let's get to your work sample in just a little bit, but I'm going to pause the video here and I'm going to pull up my notes from your observation on Friday. All right, Jordan, I'm back here, and what I have is a Google Doc that I was filling out as I was observing you on Friday. I'm going to transform this into a Word document, and I'm going to attach it to the email. My recommendation would be that you print this out and put it into tab 3 of your notebook, of your binder for the work sample. That's the tab for the evaluation. All of the evaluations. Go ahead and put that sheet that I ripped out and gave to you, I think it was the yellow one, on Friday as well, just as a nice place to kind of keep all that stuff organized. I'm not going to go through every single comment that I wrote down, but I do ask you to read through it. I typically bold questions, and I try not to take a judgmental approach. Like first and foremost, your lesson was outstanding. The lab was great. Your lesson plan was fantastic. It was detailed. There's nothing that you're doing that is like has me on alert. And so while I may not encourage you at every turn, I do want you to recognize that you're doing an outstanding job. And I thought that your lab was a wonderful example of what a high school science lab ought to look like. You know, I was thinking about the statistic that I heard recently that a teacher should really do no more than 30% of the talking in the class. And I thought, how on earth in my classes could I make that a reality? Because I'm much more probably 70 or 80% of the talking that's happening. And one of the things I realized watching a lab unfold, because it's been a while since I've seen a high school laboratory experience, I thought to myself, that's what this looks like. You had some limited direct instruction at the beginning, and then you moved around from group to group, and you engaged the groups and answered questions and redirected them. But by and large, the students were doing most of the heavy lifting. And students were doing most of the talking and most of the thinking. And you brought some closure to it at the end. But it really was a fantastic lesson. One of the other things I was thinking about this weekend is my mother-in-law is in the hospital right now. And she has some serious complications that are happening health-wise. And as my wife, who's gone to visit her every single day, and I've kind of kept the kids at home, was telling me about some of these things last night, they still don't have a solution to, or even necessarily a diagnosis of what's wrong with her. But as she was describing what these physicians and what these nurses and what these techs were doing by drawing blood and running these tests and those tests, there are several working hypotheses, and they're testing those. They're using the scientific method to essentially draw a conclusion about what's wrong with my mother-in-law's health, and then to come up with a plan to help her. And what I was thinking about is that's what we do in laboratories as well. It looks different in physics than it does biology. My example is probably more fitting to bio or anatomy or something like that. But I think anytime you can bring in real life examples of when and where students are going to be in the real world, students could be concerned about the types of charges you're talking about. And maybe you've done this in some of your direct instruction beforehand. But I think allowing students to envision what this looks like outside of Lincoln High School could be a really, really powerful experience for them. And so you have that benefit of, hey, this lab is directly applicable to electricians or to engineers or to fill in the blank of the circumstance, and try to gather engagement and motivation that way. A couple of things I just wanted to note. You referred to prior learning and prior instruction when you said, like I demonstrated the other day. And there was another point you did this as well. I suppose I should, this is the first observation that I sent to you, I suppose I should explain that basically when the bell rang, I just started a stopwatch. And so at each of these points, this is about the time where you sort of made a transition, or you said these things, or students did those things, just to give you an idea about how much time each piece of the lesson took. I asked several questions. Feel free to respond to those in your weekly reflection. You don't need to. I'm not expecting you to address all of these. This is just the sort of stuff that's rolling through my brain as I'm watching you work. You noticed right here, when students were asking you questions, you said, when two objects repel each other, are they positive or negative? And then they answer, and you say, okay, good. And that's called, and you create these blank spaces. You create stems. You guide students, but you force them to actually dig into the answers a little bit, rather than just feeding them the answers. And then down at the bottom, just the biggest reminder would be to try to get that notebook ready for my next visit. And then take a look at, I forget what page it was, but it's in the handbook for the teacher residency. And just try to begin putting some of those pieces together so that I'm able then to come in and sort of guide you through that. I did speak with Brooke, and she assured me that you are not required to do any of the co-teaching lesson plans or the collaborative logs. So basically, you're only required to do those 7 long lesson plans, and then all the other pieces that are in the notebook. So I'm also going to send out a work sample video. Take a look at that, and then send me any questions about that you might have for your Friday reflection, so that we have a place to kind of begin our conversation over that. Thanks, Jordan.